So, we discussed the frames that we attach generally on the surface of the earth, our laboratory or anywhere that we work. And the equations are mass times acceleration is equal to m into g effective. We talked in detail what is this g effective, and it depends on where you are on the globe, but the differences are quite small. The direction differs at the most 0.1 degrees at latitude 45 degrees, and the magnitudes at equator is some 0.034 or so. Okay. So, and then any other force that you apply apart from this gravity, any other force that you apply or others, let me write others, and then you have the Coriolis forces. So, these are the actual forces, then you have Coriolis force and centrifugal force m times omega cross r and minus 2 m times omega cross v. This is basically, this is the equation. Okay. And then since now this r vector is position vector of the particle from your own origin. So, this is not going to be very large like 6,400 kilometers or so, it will be in meters, 2 meter, 5 meter, 10 meter, 20 meter, 30 meters like that. And therefore, this omega square term will be very small. You remember omega is 7.29 into 10 to the power minus 5. So, omega square will be very small, and you do not have that capital R which was there some 6,400 kilometer, that made some change. Okay. So, we will totally neglect this, and this we will keep first power of omega, we will keep to see the effect of non-inertiality. So, this is it, and the kind of axis that we choose is also very important, otherwise the equations may look weird. So, what I prefer is that if I am here, this is the axis of rotation of the earth ns, and it is like this, and this co-latitude is lambda, then this is vertical. This is vertical. Vertical means this g effective, the direction of this g effective, that is our vertical. All right, even if it does not go through the center, and you know the differences are extremely small, we can always neglect that. This is our vertical. So, that vertical is taken as the z axis. I will take vertical as the z axis, vertically upward as the positive z direction, then x and y are to be chosen. So, this plane, this axis of rotation and this vertical, and in this plane if you draw this tangent here, this is north. At this place, this is north. Wherever you are, you draw a tangent in this plane, and that gives you the north, and the opposite is south. So, this opposite is south, this is south, and we will take this south direction as the x direction. All right, south direction as the x direction. So, x axis I will always take towards south, and z is of course vertical. And then you can see, if you do this cross product of this z and this x, k cap this direction, I cap this direction, and k cap cross I cap should be j cap. So, if I take a unit vector here, take a unit vector here. So, now let us come to this table. Suppose I have origin on the table, and vertical is the z axis is this, and south. Okay. So, south is here in this room, south is here. So, this is x axis, my left is x axis, vertical is z axis, and then I am doing k cap cross I cap. So, when I do this k cap cross I cap, that direction is coming towards the board, and that is east. So, y axis will be towards east. So, here if you do, you will show is going perpendicular to this board. So, you will show some dotted line and that will be y axis and that is towards east. So, this is how we will take our axis system. This is how we will take our axis system. Z axis will be vertical, x axis will be towards south, this is x axis, this is south, and then y axis will be towards east. So, wherever you put the origin, see where it is the vertical, see where it is south direction, see where is east direction, and then set up x, y, z accordingly. So, this is the system that we will be using. Now, in this system, what is this omega? Okay, what is this omega? Omega vector is here. This is omega vector. This is omega vector. So, this is omega vector. This omega vector, if you draw from the origin, this is omega vector, and this omega vector can be written as what in this plane? This angle is lambda. So, this angle is lambda here, and towards north if you extend this, this will be 90 minus lambda. So, this omega vector is omega cos lambda in z direction, omega cos lambda in z direction, and then omega sin lambda in negative x direction. So, it is minus omega sin lambda I cap, right. This north south and this vertical and this axis of rotation, they are in one plane, and therefore, we can do this resolution of vector omega vector in the z direction and in this x direction. So, it is omega cos lambda in the z direction, omega sin lambda with a negative sign in the x direction. So, this is omega, and so and g is in a negative z direction. G effective is the value of g effective whatever, and then minus of k cap. So, this is d, and then we have v. Then we have v. V will be Vx I cap plus Vy j cap. This is it. So, let us write this equation. Let me take up a specific example, and that will be free fall. Suppose I release a particle. Suppose I release a particle from some height h above the ground, and I want to see the path of the particle, time taken to fall to the ground, and so on. So, a particle released from rest So, what I have initially, suppose this is okay, this is the x axis, y axis, z axis, and the particle is released from here and this height is h. So, at t equal to 0, x is equal to 0, y is equal to 0 and z is equal to h. So, it is released from here and the velocities are 0, Vx is equal to Vy equal to Vz equal to 0. This is the condition. And now I want to see what will be the path of this particle, how much time it will take and all those things. So, how do I write equation? Mass times acceleration. Mass times acceleration is equal to m into g effective. So, m into g, let me write g because I will not be using both together, g and g effective. So, it is g effective, all right. So, m times g in a negative k direction. So, minus here and k cap here, and then no other forces are there, it is free fall. So, this term is not there, this is minus 2m. Then omega vector is omega cos lambda k cap and minus omega sin lambda and I cap. This is it. Cross V is plus Vz k cap. So, V is Vx I cap plus Vy j cap plus Vz k cap. Let us do this cross product. So, this is m you can cancel, m you can cancel from everywhere. So, A is equal to this, A is equal to minus G k cap, and then this minus. Now, this cross this. So, start from here, omega cos lambda k cap, and here it is Vx. So, Vx and k cap cross I cap is j cap. So, this much j cap, right, I j k, k cross I is j. So, k cross I is j. Then this term plus omega cos lambda into Vy, omega cos lambda into Vy, k cross k cap cross j cap, k cap cross j cap will be minus I cap. So, this is minus I cap here, and then k cap cross k cap is 0. So, this is done, this is done. Now, come here, this one. So, minus omega sin lambda, and then I cap cross I cap is 0. So, come here, minus omega sin lambda, and then Vy, and I cap cross j cap, which will be k cap. So, this is k cap, and then this one minus omega sin lambda and Vz, and I cap cross k cap, is minus j cap. So, this becomes plus here, and this becomes j cap here. Okay. Now, write the x component, y component, z component. Ax, x component of the acceleration, Ax is equal to, so search for I cap, here it is minus omega cos lambda, then Vy. Okay. So, minus omega cos lambda Vy, that is here, and no I cap here, no I cap here. So, this is Ax. Then Ay, I have k cap, then k cap cross j cap is I cap, and then that is it, right. Then you have Ay. So, Ay is equal to, search for j cap, where is j cap? Here is j cap. So, minus I omega, Ax is equal to minus I omega, but I also have a minus here. So, it is plus. Ay. So, minus omega cos lambda Vx minus omega cos lambda Vx, j cap, I am looking for j cap, here is j cap, and then here is j cap, minus omega sin lambda, that is j cap, and k cap is minus g. So, Az is equal to minus g, and then k cap I have to search minus here and minus here, plus omega sin lambda, and then Vy, that is it. So, this is it. So, let us compare once again. Here is acceleration, and I am writing the three components, x component, y component, and z component. This 2 is here, and the 2 will be there. So, everywhere this will be 2 here, this will be 2 here. So, maybe I can put minus and 2 common, and then this, and where is the velocity? Ay, y component is v omega cos lambda Vx is there, and then y component is here omega sin lambda and Vz. So, this Vz is there, all right. So, 2 here, that is it. Y component is minus 2 omega cos lambda Vx there, then y component is minus 2 omega sin lambda Vz is there, z component is minus g from here and then from here. So, minus plus 2 omega sin lambda Vy, that is it, right. So, these are the equations to be solved with this initial condition. Okay. So, how do we go about it? Start with first integration. First integration, of course, you can do this Ax. If when you integrate this dt and then integration, Ax will give you Vx equal to what is Vx? Vx is integration Ax dt, dVx dt. Ax is dVx dt, and therefore this is. So, Vx, and this side is 2 omega cos lambda, that is constant, and Vy similarly when you integrate, it gives you y. It gives you y. Vy when you integrate, it gives you y plus some constant, and that constant you should get the value from the initial conditions. At t equal to 0, y is 0 and Vx is also 0. So, y is 0 and Vx is also 0, that tells me that this C is 0. So, I can remove this. Similarly, Vy here, Vy is equal to, I am integrating minus 2 omega cos lambda, that is constant, and Vx when you integrate you get x, and plus omega sin lambda, and Vz when you integrate you get z. So, up to this point it is very simple. Then here it is, so this was Ay, and from Az you can get Vz is equal to minus Gt and plus 2 omega sin lambda, and Vy dt will give you y, of course plus constant and plus constant here. We will just see what these constants are. First, this constant at t equal to 0, x is 0, z is h, and Vy is 0. So, it gives me, this equation gives me 0 equal to, Vy is 0, minus 2 here, x is equal to 0, omega here, sin lambda here, and this z is h plus c. So, c is equal to minus 2 omega sin lambda plus 2 omega sin lambda into h. So, that is c, that you have to write here, plus 2 omega and sin lambda and then h. So, this is that constant. Okay. So, 2 omega sin lambda you can take common from these two terms, and what you can write here is this term and this term together. This you can write h minus z, 2 sin lambda h and minus z. So, you can combine this and write 2 omega sin lambda and h minus z. So, these two terms can be written as this, that is C. In this equation, what is C? At t equal to 0, y equal to 0 and Vz is also equal to 0. So, this C is 0, this C is 0. So, these are the equations, these are the three equations. Let me write it more cleanly. Vx is equal to 2 omega cos lambda times y, this one. Then you have Vy, Vy is equal to minus 2 omega cos lambda minus 2 omega I can take common minus 2 omega, then cos lambda times x, and then here it is minus or plus or minus z h minus z here and sin lambda here. Okay, what we have done for Vy minus 2 omega I am taking global common. So, it is cos lambda time x from here, and these two terms if I take minus 2 omega common, then from here minus 2 omega when I am taking common sin lambda into these two I am combining, this was this plus this was 2 omega h minus z, minus 2 omega I have taken. So, sin lambda here and h minus z with a negative sign here. So, this is Vy, and Vz is equal to minus Gt and plus 2 omega sin lambda times y. So, up to here we can go. I know the velocities if I know the position x, y, x and y if I know, then z also I need x, y, z if I know, time if I know, then I can write velocity is not a great thing to achieve. Okay. We have to go further and write x, y, z as a function of time, but then now if I want to integrate this, the y is here I cannot integrate, or if I integrate this Vy, then x is there I cannot integrate, z is there I cannot integrate. So, we have to do some approximations. So, let me make some space. So, now remember we had neglected omega square term and retained omega term. So, our results that we are deriving are up to the order of omega, and anything which contains omega square that we will neglect, because omega remember 7.29 into 10 to the power minus 5. Now, if I see this equation Vz, it is minus Gt plus 2 omega sin lambda into y. Now, if there was no rotation, there was no question of any y, because when I drop there is no force in y direction, initial velocity in y direction is 0, there is no acceleration in y direction, and therefore, it does not go in y direction or in x direction, it just goes in negative z direction. If at all there is some y and if at all there is some x, that is only because of the presence of omega, and therefore, this y and x if at all they are there, they will be in the, they will contain that omega there. They cannot be without omega, because it is only because of omega. When you put omega equal to 0, that term should go away. If you put omega equal to 0, that term should go away, because then it will just fall vertically. So, this y will have omega in it, and therefore, this term will be of omega square type. One omega is here and one omega is coming from here. So, this term will be of omega square order, and therefore, we will neglect it. Okay. Consistently from the very beginning we are neglecting omega square term and retaining omega term, and therefore, let us rewrite Vz. What is Vz? Vz is just minus Gt, and therefore, z is equal to h and minus okay, this is minus half Gt square, our usual equation, because if I am neglecting this, it is just simple fall. Vz is equal to minus Gt, and if I calculate how much is z, remember we are dropping it from here, and this is z is equal to 0 and this is z is equal to h. So, it moves a distance half Gt square, and therefore, z is equal to h minus half Gt square. So, this is there. Now, let us look at this term here. It is h minus z, and h minus z is half Gt square. This is that h minus z half Gt square. So, look at this equation Vy. Vy is equal to minus 2 omega and x. Once again, x is in the direction of south. So, if you are dropping, it should just go vertically. There should be no horizontal deflection, because there is no force in the horizontal direction, but because of omega, because of this Coriolis force, you can get something, but then it should be of the order omega. So, this contains omega, here is omega. So, we will neglect this term, because it will be of omega square type, and then come here. So, it is plus 2 times, so plus 2 times h minus z, which is half Gt square, and times sin lambda, This is Vy, and if this is Vy, now I can integrate to get y. So, y is equal to Gt cube by 3 and then sin lambda. This is y. So, there is a deflection in east direction. Y, remember, y axis was taken towards east. So, if you drop it, it does not go in the direction shown by my plumb line. My plumb line is showing that z direction. The z direction is taken along the vertical, our vertical. Okay. So, if I just take a plumb line, just suspend a pendulum at rest with respect to me, that thread is vertical, and if I drop a particle from here, it will not go in that direction, it will be deflected towards east according to this equation, and more time it spends in air, or we are of course neglecting air resistance, etc. So, more time it spends in air before reaching the ground, more is the deflection towards east. What happens to x? Vx is equal to 2 omega cos lambda times y. Once again, this y is coming only because of omega. Where is my omega? This omega I have not written here, this omega, 2 omega. Okay, Vy is 2 omega, this is 2 omega. So, 2 omega times h minus z. So, 2 omega times h minus z, and that 2 omega is here, and h minus z is half Gt square. So, this is omega, of course, this is omega. So, y contains omega, y is because of omega only. The deflection towards east is because of omega only. So, omega has to be there, and therefore, this contains omega, here is omega. So, any x deflection is of the order of omega square, and we neglect that, and therefore, the deflection, the actual deflection will be in the east direction. How much? Typically how much? So, we can put some numbers. This you can write in terms of height also, because we know this equation, and therefore, when your z is 0, when z is 0, when does it reach here? When this z becomes 0. So, 0 is equal to h minus half Gt square, and therefore, t is equal to 2h by g square root of that. So, if you write this in terms of h, so in place of this t, you will be writing this. So, you have y is equal to omega g by 3 sin lambda, and then t cube, that means the square root of 2h by g cube, that is it, or omega here by 3 here, sin lambda here, and then square root, this is 2h cube here, and then this is g cube here, 1 g cancels with this, and it will be g here. So, this is your y, this is your deflection. If you drop a ball from height h and it falls on ground, it will also be deflected towards east with this much of amount. So, let us try to put some numbers here. Okay, so let us take lambda is equal to 90 degrees. Where are we? Lambda equal to 90 degrees. Where are we? We are on the equator. So, if we are doing the experiment on equator, then this sin lambda is 1, otherwise you will multiply by sin lambda, omega by 3. Omega is 7.29 10 power minus 5, everything in SI units, by 3, and then square root of how much h I should take. Let us take 20 meters. Let us take 20 meters. So, we have dropped our ball from 20 meters of height, and we neglect all that air resistance which is there in this 20 meters. So, this is 40 cube. So, 40 into 40 and into 40 and divided by g, which is 10. Okay. So, it is 7.29 into 10 power minus 5 divided by 3 into 4 into 4 into 4. So, 16 and then 64 and 00, 64 00, so 80 meters. If I write in millimeters, it will be 7.29 into 10 to the power minus 2 by 3 and 80 millimeters. So, that will be 7.29 into 0.8, okay, and divided by 3. How much is this? How much is this? So, 2 here, 4 here, 3 here, and into 0.8 millimeters, 4 here, 34, 4 here, 3, something like this. So, something like 1.9 or 2 millimeter, okay, let us say 2 millimeter. So, that is the order. That is the order. If you drop something from 20 meters and it falls through those 20 meters, there will be 2 millimeter deflection towards east when it reaches ground. So, that is the kind of effect. So, for our normal daily life routine, it is extremely small, we can neglect, but for like say missiles going to hundreds of kilometers, we have not done projectile. Similarly, in a similar way you can do projectiles, project it, and the Coriolis force that show some sizable effect there. If you are targeting some ship, perhaps that ship will not be sunk because of your missile, because your thing is deflected because of this Coriolis force. Okay, so we will stop here and you do an exercise. Throw the particle from z equal to 0 upwards, so that it reaches a height h, the same height h, and see that if I am throwing it vertically upward from z equal to 0 and it reaches a maximum height of h, how much is the sideways deflection, and whether it is towards east or towards west or south, north or any other direction in horizontal plane. So, that you in a very similar fashion, in a very simple way, we have done everything, only you have to rightly put the symbols and the signs and get how much is the deflection as it reaches the highest point and in which direction. So, we will stop our non-inertial frame discussion here, and from next lecture it will be rotational dynamics, rigid body dynamics.